Hello, so today I'm just going to quickly talk you through how you would approach an AS Chemistry Paper 3. So this is a CIE AS Chemistry October-November 2025 Paper 3 Variant 3. It's a paper that I've already solved on my channel, so today we're just really going to go through the sort of things you need to be mindful of when you're actually doing a real-life Paper 3, okay? So our first half of the paper is our quantitative analysis, where all you're doing is you're carrying out an experiment, you're recording your results, and you're carrying out a few calculations. I feel it is very key to actually understand what you are doing, understand each step you are making and why you are making it, and to actually know what it is that you are measuring. So before you do start your experiment, please ensure that you have fully grasped what is actually being conducted in this experiment, why we're doing all of this. And I think it's really worth noting that I find it saves time to highlight wherever it says record in your methods, because it is likely that you will have a table right after an experiment. However, in this part of the paper, they actually gave out the headings for the columns in the table you needed to produce. So they asked for the volume of FA1, the volume of distilled water, the reaction time, and the reaction rate. So I've just done that each time and produced my 4 columns. Now, having conducted the 5 experiments, because really this was dilution, and just writing out these 4 column headings, you have gained a mark, right? For the second mark, you needed what? Units. So it's very important to not forget your units, because these are easy marks. With volume, it's always centimeters squared. With time, it's usually seconds. And with rate, because rate is really what? It's 1 over time. In this case, it was 1,000 over reaction time. So if they want you to use a particular equation, then you'd use that. But generally speaking, reaction is just the reciprocal of time raters, okay? Another mark is rounding. Now, you need to make sure that when you're giving your results, you're producing results that are reasonable. So when it comes to the devices you use, the apparatus that you use, there's limitations. So, for example, if we're using a burette, your graduations limit you. You can't give your answer to the nearest 3 decimals, because frankly you can't read to the nearest 3 decimals. So in this case, the time needed to either be recorded to the nearest second, for example, and there has to be consistency throughout. So if you were to give one piece of data for your time to the nearest second, all of your results must be to the nearest second for your time. They also needed asked for your volume of water and FA1 to be to the nearest 2 decimal places, and to end with either 0.0 or 0.5. The reason for this being the fact that you can only measure to the nearest 0.5 centimeters cubed. Okay? 4th mark was for being reasonable with the range of dilution. So obviously you need to make it up to 40 centimeters cubed in this case. If you add 1 centimeter cubed of distilled water and 39 centimeters cubed of FA1, that would be unreasonable. Very. So you wouldn't get the mark in that case. Another mark for the rates being to the nearest 2 to 4 significant figures. So as you can see, you need to be really reasonable. You need to be aware of the limitations to the apparatus. So you can either do this beforehand and save yourself the worry or the uncertainty, or you can actually take a look at your apparatus and think to yourself, what can I measure to the nearest? Is it to the nearest centimeter or to the nearest half a centimeter, etc.? So in this case, we also were told to plot a graph. Now, the graph, really, you would plot your axes. Of course, you get a mark for the axes being labeled and having had their units, but also a suitable scale, and of course plotting and drawing your best line of fit carefully. when it comes to scales, usually they fall within 2, 5, 10. So either going up in 2s, going up in 5s, going up in 10s. Now you have to see what your lower end value is and your upper end value is, and find a middle ground so that your graph covers at least 3/4 of the grid that they have provided for you. You also need to be mindful of and aware of the types of experiments that you carry out. So you should be familiar with whether you expect your graph to be a curve or a straight line. And this will help you figure out if you're going on the right track and whether or not you've done it right. Obviously, it's not 100% guaranteed that you will be certain of what type of line of best fit, but there are times where it's predictable, and it's really nice to be reassured when you find that the line that you have drawn is what you had in mind. Okay, so we then had a second experiment, and like I said, save yourself time and highlight when they say record. And as a matter of fact, they didn't give us the column headings for this. And if you can see, record is mentioned 6 times, and guess what? You need to have 6 columns. So don't forget your headings. They're all the record hints will send you in that direction. Don't forget your units, grams or kilograms, usually grams per mass, degrees Celsius for temperature, centimeters cubed for volume, seconds for time, etc. So know your units. And again, you get marks for rounding to the nearest 2 or 3 decimal places when it comes to balances. So your balance might record to the nearest 2 or the nearest 3. You have to be consistent with it throughout. You get marks as well for being within the range that they expect of you. Then, of course, you're told to carry out calculations. Most of the time, they are looking for 2 to 4 significant figures. Also, be wary of the small things, like when it comes to energy changes, for example, you have Q equals mc delta T. The value we get from this equation is in joules, but with enthalpy change, it's in kilojoules. So don't forget to do stuff like dividing by 1,000 in between. Right? Then for our second half of paper 3 is our qualitative analysis. You're basically carrying out a lot of tube tests. There will be color changes, there may be gas evolutions, and you just need to keep testing them and recording the observations you make. The 2 most important are actually including color changes as well. So you look out for color changes, precipitates, their colors, whether they are soluble in excess or not, and then if any gases are produced, any vapors, whether you can identify them based on a test that will further confirm its identity, basically. Okay? So really what you should be doing is, besides just carrying out the tube test and recording your observations, really you should be asking yourself, when I'm conducting this test, what is it that I'm looking for? So for example, tests 1 and 2 are aqueous sodium hydroxide and aqueous ammonia. At the very end of your paper, there is a table with reactions for cations, and you have your sodium hydroxide and your ammonia in these 2 columns, and all the types of tests, okay? So we're on the lookout for any of these ions, right? So when we produced an observation, we can then come to a conclusion based on our table. So in this case, I believe we had a red-brown precipitate in these 2. And if we go to our table, that must mean that we have Fe3 plus ions, right? So we can exclude Fe2 plus ions in this case, okay? So stuff like that. Here, we're testing using sodium carbonate. Sodium carbonate is what? It's a base. So really, we're probably testing to see if there's an acid. Most likely. And if there is, there's going to be what? CO2 gas. To confirm the identity of CO2 gas, we know to bubble it through lime water. If we bubble it through lime water, we should see cloudiness, okay? the test with barium chloride. So we're on the lookout of either sulfates or sulfites, and then we further differentiate between the two. And then down here we have acidified aqueous potassium magnate. Does it remain purple? Does it become colorless? What does that mean? So really, we should have at least a small idea of what we're looking out for. So that kind of narrows down our options, and hopefully we're able to come to a conclusion. What I will say is when you're making observations, give as much detail as possible. Don't just give us the precipitate, give us its solubility. Don't just give us fizzing, give us further testing, okay? Yeah, so obviously this isn't as detailed as I would like it to be, but for the convenience of time, I have just quickly produced this video just as a kind of refresher to just, have a simplified overall idea of how a paper 3 AS chemistry question paper is like and how to go about approaching it in brief terms, of course.